Hello and welcome to the video lecture explaining the options for how we move data amongst these distributed databases. The first would be data replication, and this is more of the homogeneous environment where we copy data that's distributed to our different sites. We also have horizontal partitioning, which we spoke about in a previous chapter, might have even been IT 117, where different rows of a table are distributed to different sites. We also talked about vertical partitioning, where different columns of a table are distributed to different sites. And then we have combinations of all of these. So quickly, data replication has a lot of advantages. It's reliable. It has a fast response time because the data is being replicated everywhere. It doesn't have any integrity issues because all of the data is refreshed regularly. It decouples the nodes, so transactions proceed even if some nodes are down. So if you have network problems, these transactions continue because once the node comes back up, it'll get refreshed from the central node. And it'll reduce network traffic at prime time. So what you can do is you can delay updates during high traffic periods if possible. Obviously, in a Citibank example, you're not going to be able to do that, but in many other scenarios, that's perfectly possible. The disadvantages are that data replication requires additional storage space. There is additional time associated with these update operations to happen, so you have a significant overhead addition. There is data replication. Data replication is a complex and costly operation, so not to be taken lightly. And there is an integrity exposure in case, because once you have incorrect data, it gets replicated everywhere. This is better used for non-volatile read-only data when you're doing replication, but obviously you're going to have to replicate some of your transactional data. So when we talk about replication, we have push replication, where the updating site sends changes to the other sites. And then you have pull replication, which is like, I call that subscriptions. So receiving sites control when the update messages will be processed. So it's like subscribing to a newspaper and saying that you either want the daily version or you just want the Sunday version. So that's pull replication. And then we have different types of push replication. We can do snapshotting, which we've spoken about with data warehousing. So changes are periodically sent to the master site from the local sites. The master site collects and updates the log, and then full or differential or incremental snapshots are distributed, and you have dynamic versus shared update ownership. You can have near real-time replication, which means that updates are broadcast without requiring any kind of confirmation. This is done through the use of triggers, which we've already spoken about, and these update messages are stored in a message queue until processed. So we send the updates out, but the local sites, their systems reserve the right to actually hold off, depending on network traffic and local updating, can hold off until such time as processing those updates would be easier and faster. There are a lot of issues, all right, for data replication. There's a timeliness, right? These are not actual real time. And if they are trying to be real time, there's a high cost associated with that. Not all database management systems are capable of supporting data replication. There's, of course, performance issues. There is differences in networks. So all of your networks might not be the same type of network, so that can complicate replication. And your network might not be able to handle full snapshot replication. Just simply the bandwidth won't allow it. So that has to be taken into consideration. We're talking about horizontal partitioning. We're talking about different rows of a table being stored at different sites. The advantages are that the data is stored close to where it's being used, so it's efficient. You optimize local access, which means the local user realizes better performance. Only relevant data is even available, which means from a security perspective, you're only guarding relevant data. People who shouldn't see data, just it isn't available, it's not even on the site. And there are unions across partitions, which makes the querying easy. The disadvantage is that if you want to access data that's across the partitions, in other words, stored at different sites, you can get inconsistent access speeds from those various sites. And there's no data replication. So if one site goes down, you lose the availability of that data from the other nodes. So for instance, if this was a bank, these are records associated with a particular bank, we have two different branches. So if we wanted to horizontally partition this, we would partition out so the Lakeview data would be stored at the Lakeview branch, and the Valley branch's information would be stored at the Valley branch. Then we talk about vertical partitioning. And when we talk about vertical partitioning, we're talking about actually different columns of a table being stored at different sites. The advantages and the disadvantages are the same for horizontal partitioning, except that combining the data across the partitions is more difficult because it's joins instead of unions. And we know that from chapter 7, that unions are much faster than joins, especially in a distributed environment. So when we look at an example like this, we have a processing system for a manufacturing company. We've got our corporate core network, our corporate data center, and our corporate database servers. Then we have our manufacturing network in one location, our departmental network in a different location, and our engineering network in a different location. All performing, as you can see, different functions at their workstations. So when you look at horizontally partitioning in an environment like this, we see that this would be a record associated with this manufacturing company. But then when we vertically partition this, we get our part numbers and our drawing numbers needed by the engineering department, whereas the manufacturing department needs to know the part numbers, the names, the cost, and the quantity on hand. So, yep, ran quite a bit long on that one, but that is the end of my video lecture associated with the options for distributing data to your distributed databases.